Think about it. Temperature. The function f of x is equal to 9 over 5x plus 32. Can be used to convert temperature of x degrees Celsius to its corresponding temperature in degree Fahrenheit. A. Use the expression for f, for this function f, to make a conceptual argument to show that the function f has an inverse function. And if we are putting this function in a Desmos, or if we want to, for example, manually to graph a function without utilities, we can do either way, but because the technology makes a little bit easy life, so you can plug in a graphing utilities, or as I did, for example, in a Desmos, and I got this function here. And already when we see this function is a linear function, and to answer on the A, we already know all the inverse function they have, or the linear function they have an inverse function. And as we see here, this linear function is already every time is increasing, and this function here, linear function, has an inverse function. So, and if we are doing, for example, with a vertical line test, is going to pass. Even if we are doing a horizontal line test, this is going to pass. Therefore, the function f in the A, let me write here, in the A, function f is a linear function, so we can write is a linear. Because it's a linear, it means it has a, therefore it has a inverse function, f minus 1, it has the linear function, it has the inverse function. And f represents, if we are looking here, f, if we look at the formula, it means f converts the Celsius to Fahrenheit. This function f represents the formula for conversion of the Celsius degree into the Fahrenheit degree, as is mentioned here in the beginning. And now in the B says, on the B says, what does f minus 1 of 50 represent? F of minus 1. But first of all, let me find the inverse function. What is the inverse function of this? If we find the inverse function of this function here, f of x, first of all, let's say f of x, we substitute with the x, and this is equal to 9 over 5. And I'm going with a shortcut here, 9 over 5. Instead of the x here, I'm interchanging. I'm going with a shortcut. Instead to go with the y to apply all the rules, I'm applying here the inverse function of f of x. And this f of x plus 32. Plus 32. And if we subtract both sides by minus 32, we're going to get x minus 32. X minus 32 is going to be, because in this side minus 32 plus 32 goes away, and this is a 9 over 5. 9 over 5 f minus 1, f inverse function of x. But again, if we are multiplying a whole with a reciprocal 5 over 9, if I multiply everything by reciprocal 5 over 9, what's going to be on this side here, on the right side, is going to remain just the inverse function f of x. But on the left side of the function is going to be 5 over 9, 5 over 9 time x minus 32. Minus 32. So that's what's going to be. And if we look at here, for example, right now, the inverse function, f of inverse function is the 5 over 9 x minus 32. which if we are looking here on the corner on the top represents when we convert Fahrenheit into the Celsius, we already have a C is equal 5 over 9 F minus 32. So it means the conversion from the Fahrenheit to Celsius. And this here 5 over 50, pi of 50, what the inverse function of 50, what represent? Here represent this way. Now 5 over 9, and instead of the x I am plugging here a 50 minus 32. And let's solve this problem here. When we solve this problem f of minus, let me write this with a different color. When we find the inverse function of a 50, after all the calculation here, what we get? Let me take one shortcut here. 50 minus 32 is 18. 18 times 18 divided by 2 by 9 is a 2. 2 times 5 is a 10. So it's going to be 10. So it's a 10. What it represents? It represents when we want to convert a 50 Fahrenheit into the grade Celsius, is going to be 10 grade Celsius. So 50 Fahrenheit, here 50 Fahrenheit, when we convert into the Celsius, is going to be 10 grade Celsius. So that's what it means, the inverse function.